Let's start. So very briefly, my name is Atte Sillanpää. I'm working at CSC as an application specialist. My background is in computational chemistry, and I have here my colleague
Kim Mattila from CSC also, and working also with the application support, also in biosciences area, but in chemistry. So,
yeah, so welcome.
Welcome.
So the idea today is, or the topic is to introduce the usage and the benefits of using the CSC supercomputing and data management environment, and just to give a very brief overview on how to get started. And without further ado, the topics for today is that a brief description of the services. There's a lot of information available on the web pages. The services are mostly free for you. They have been already paid by the government. And that in addition to giving access to our hardware, you also get access to support and maintenance. So we think there's a lot of benefits in this. After that, we'll briefly show how to become a customer and how the user accounts are being managed and the services are managed. Then we briefly show a schematic overview of the CSC environment and how supercomputers differ from laptops. Then, as a very particular case example, how to move files back and forth from the CSC environment. This is a thing that can be done efficiently or in a more cumbersome way, and we're showing one or two ways how to do it in a practical and efficient way. Then my colleague Kimmo will show you an example of a more or less complete workflow for doing some science with data in the CSC environment, and then finally wrap up and show some links where to get more information. So the first thing I mentioned, okay, so if you have any questions, then you can ask at the time when you can think of them, but we prefer to answer them towards the end of the webinar so that they can be nicely edited in the recording. So for the research CSCFI pages, this is the page that I would recommend you to go to when you have questions or you want to find information for researchers about using the CSC resources. We also have the company page, www.cscfi, which is more like about the overall services that CSC has, and it's maybe more tailored for decision makers and so on. But if you are a scientist and you want to get your hands dirty with actually doing science, then I think these research pages are more useful. You get more quickly to the actual information. So very briefly, research CSCFI, on the landing page, you'll find links to training activities, coming service breaks, and so on. You'll also find with 2 clicks a list of supported software, the software that you can use with licenses available from CSC, or those that have been already installed on the CSC servers, and you have instructions on how to use them. You have user guides for the different platforms, a general CSC user guide, the cloud user guide, and so on. So from there, you will learn how to use efficiently these resources. And of course, how to get access. There's a bunch of videos showing what to fill in where. So let's briefly go to the web pages. So this is actually the landing page, and the content has been categorized in these topics. And if you want to do, let's say, molecular dynamics, you would click on the computing and software, and on the right-hand side you'll find software and databases, and from here you'll find a list of from A to Z, or actually halfway there, the first 100 items on the software that have been installed. Or if you want to narrow it down based on categorization, you'll get a list of the different chemistry software. And for example, how to use Maestro, you will find a brief description and on which servers it's available, how to use it, who can access it, and there's actually an embedded video on how to use it efficiently. So there's a similar page for each installed software. So this is one way to look for which software to use or whether your preferred software is supported by us. Another way is actually to log in on for example, on Taito or Sisu and give module avail or module spider command, and which will show all the different module environments that are actually used to initialize the software for usage. Okay. The next thing we wanted to show is getting access. So in the first step in getting access is to set yourself a user account. If your institute is a member of the Haka Federation, then you can do this as a self-service. And I think this is a link that would take you to the software or the information page that shows you step by step how to do it. But this is the first step. If your institute doesn't have a Haka account, then there are instructions on how to send an email and what to include in that email. Once you have a user account, then your user account should be joined in an academic project or a computing project. And this is important because the access to different services, like different computing resources, is managed at the project level. So if you work on your own project, you can set up your own project yourself. And in this case, you will be the PO, project owner, or principal investigator. And then you can manage, you can apply for more resources and so on. And as an example here, we have access to Taito, which actually comes by default currently. In the future, we'll see how that works. But if you want to have access to the cloud resources or to Sisu, then you need to apply for this within the project. And at the bottom of the page, there's a link to these special or very detailed step-by-step instructions on how to do this. In this confusiogram, I will try to explain the idea that what does it mean that the resources and access is being handled and managed as projects. So on green, we show the user accounts. And when you set up your user account, automatically you will have a personal project. But you shouldn't use this personal project to do any calculations, but instead you would apply for a computing project, or your supervisor would apply for a computing project, and your user account would be added. It would become a member of this computing project. And now, as the next step, you can apply for access. For example, access to these purple services, access to Sisu, or access to cloud. And once, by default, you get 10,000 billing units, which is a way of managing and sort of counting how much resources you have been using. Then once the default 10,000 billing units have gone, then you can apply for more. So for example, 100,000 or 1 million billing units, which currently translates roughly to 500,000 core hours. So at this point, the same user account can actually belong to multiple projects, and then you just have to manage yourself that which work belongs to which computing project. This is perhaps still a little bit unclear, but for that purpose, I have a third slide on the topic, which goes through step by step. So once you get yourself a user account, you will automatically get your own personal project. And currently you will get access to the Taito computing server and a saldo of 1,000 billing units, which translates roughly to 500 core hours. To start doing science, you need access to a computing project, which you can apply by yourself, or if your colleague or supervisor or somebody with whom you're working with, if they already have a computing project, then you can ask them to invite your user account as a member of this project. In this case, we have some famous sounding guy as the project owner. And in principle, there is no maximum limit for the saldo, but by default you get 10,000 billing units, but then you can apply for more. And on the scientist user interface, which is the sign-in portal, you fill in a simple form where you specify for which project you're applying for more resources, what have you done previously, what you plan to do in the future, and which are those publications where you have that you have made with the CSC resources before, and where you have acknowledged that you've been using CSC resources. In this computing project, you can get access also to other services than just Taito, for example, SISU and Cloud. And now these are properties of the project. And then the project owner will invite you and your co-workers to become a member of this project. So these would be the principal differences in the personal project. Once you run out of this saldo, you cannot apply for more, and then you can't run any batch jobs at this point. In the computing project, there is no theoretical limit. So once you run out of resources, you can apply for more. The project can have multiple members, which make it easy, for example, to share files. And you can access different service resources as well. Yeah, okay, so there is a question that whether it's possible to ask for more resources without publications. Yes, it is. It could be that the resources run out, or the publication is in being peer reviewed, or so. So the idea is that using resources aims for publications, and if the researchers or if the project has used a huge amount of resources and no publications come out, then at this point we start to ask for, okay, that where did the resources go? But if you have a good explanation, then it's fine. So it's not a requirement. But all those resources all those publications that result from using CSC resources should acknowledge that you got some resources from CSC. So that is our way to show to the ministry that people are using for the resources for doing science, which is the intention. That's a good question. Okay, so finally, okay, so with the personal project, you also get access to Chipster and Kielipankki, some particular services. So those are covered already by the personal project. And also, then how much is this 1,000 billing units? Well, it's 500 core hours, and if you run with one CPU full time, or you have one CPU allocated for you, it would be 3.5 months. But really, it depends. So I mean, if you do some molecular dynamics and you run in using multiple cores at the same time, you could actually burn a lot of CPU time in a week.
Another question.
Okay, so there's a question. Should I acknowledge even if I'm using just the storage spaces? That's a good question. It doesn't hurt if you acknowledge that. For the storage, currently, I think you don't need to ask for additional billing units, but in the future, it depends on which type of storage you will use. So in that sense, it would be advisable. So this is now my guess. You could ask this specifically from the service desk, and then we can forward the question to somebody who actually is certain of this. But if it's not a problem, we would of course be happy if you acknowledge the usage. Very good. So the next topic is what is the difference between using a laptop or a local workstation, and what is it to use a supercomputing environment? So in this graph on the left, you have your own PCs or laptops inside your institute firewall, and then through the internet, you're using either SSH or SFTP, or well, yeah, for now, to connect to Taito or SISU login node. So you're not actually logging into the supercomputer compute nodes, but the usage pattern is that you log in on a login node where you prepare your job, you describe in a using some files that what kind of computational jobs you want to do, and you let the queuing system to look for the right resources in the actual supercomputer and run the jobs. So Taito and Sisu have their separate login nodes, but they have access to the same parallel file system, and then both have access to their own separate compute nodes. In addition, there is something called the object storage, which started as the storage for the cloud resources, but currently it can also be accessed from Taito and Sisu, and it can be accessed from your own machine through SFTP or some other protocols also without going to the Taito or Sisu login nodes. So on your own laptop, what you would do, you would just directly run whatever code you have, and it would start running immediately, and the remaining resources would be kind of competing with the code that you're running. If you want to run stuff and jobs at the CSC user or the CSC environment, you would first take an SSH connection to the CSC machine. Then you would prepare your jobs. You would write a batch script description of what you want to do, how much and what kind of resources you want. Then you submit this batch script, and then the queuing system will take it to the compute nodes and then run it with, for example, 512 nodes. So this is the difference between running locally and running in the supercomputing environment. If you want to run some simulations or whatever applications that require a graphical access on the Sisu or on the CSC environment, then if you run a Linux or a Mac system, you could add an SSH minus capital X, and you would tunnel the graphical access through the SSH connection. This kind of works, but it's very slow. The data center is in Kajaani, and it's a little bit far. So there is a solution called No Machine Remote Desktop, and the way to use that is to install this No Machine client, and in this case, please install only the desktop client, not the desktop, not the remote desktop. It also comes with the server, and you don't want to run the server on your own machine. And in this case, you have to pass the firewall. It requires, I think, by default port 4000, but you can tailor that to also to some other port, or then you can use a proxy. So this is something that the universities typically don't use, these firewalls that limit these ports, but we know that in some other research institutes, the firewalls are much more strict. And in this case, to get really the connection working to No Machine, you might need to talk to your local IT support. Actually, installing the No Machine server, I think that in Windows 7 at least, it requires admin privileges. On Windows 10, it might not need. With Linux and Mac, I'm not sure, but I expect that you also need some admin level privileges. So this is also installing the client is something that you probably need to talk to your local IT management. But once you have it, you can take a client connection to our No Machine server that sits in Kajaani. And this red line now is the connection from the No Machine client to the No Machine server. And this has a very good bandwidth, or it is able to show with a lot of a big frame rate graphical stuff from the remote side. Once in Kajaani, from this No Machine server, it runs only a very stripped down Linux desktop, and the only things you can do is to take an SSH connection to Sisu or Taito login node, or maybe I forget if I have a slide on using the Taito shell, which is meant for interactive usage. But since this is a local connection, then forwarding the Xgraphics actually works. So if you want to use remote graphics, instead of taking an SSH connection directly to Taito or Sisu login node, you can use this No Machine client. In addition to giving better remote graphical performance, you can also suspend the session. So if you close the lid of your laptop, it will cut this connection, but these connections from the No Machine server on, they still remain active. So once you reconnect to No Machine server in Kajaani, you can continue where you left off. So this is sometimes very convenient. Okay, so you open a terminal here and you can run graphics nicely. You can show the graphical terminal on your own laptop. The next typical thing, a problem or a task to overcome to get started is how to move files back and forth between your own machine and the CSC system. So here you have some files on both ends, and what you can do is install something called FileZilla. There's a bunch of different alternatives like WinSCP or CyberDuck. FileZilla works on Mac, Linux, and Windows. This is the one that I'm using. I find it very convenient. And once you open that, you have a kind of file manager type window where on the other end you have the local file system and the other end you have the remote file system. And there it's easy to move files back and forth. And here we have a fancy animation of files going back and forth. And now we try if we can do that in real time. So here we have the web page, and here I have FileZilla. So this is my local file system, and here so we have some lag in the display. So let's wait for a moment. Well, at the top there are boxes where you need to fill in the host, username, password, and port to connect to. So now we want to connect to Taito CSC FI. My username is Kuukko. Then I need to fill in my password, and since we're using the SFTP protocol, we're using the port 22. And the first time you have to fill in all this information, and if this is the first time that you're connecting to Taito, it will ask whether you trust the fingerprint of the remote server, and then you say yes. But if it keeps asking you, then you should worry. And now the next time I don't need to fill in this anymore, but actually you will have a quick connect bar here where you can just select the Taito. So this is quite convenient. So let's say that now we are in the home directory of the remote system, of the Taito system. So let's go to a working directory. So now it shows the contents, so there's nothing in there. And now what you do is you click and drag the file and you get it over. And that was quick. Let's see if I have something bigger. Let's see. Let's move this one. Okay, so it wasn't really bigger. And the same would work all the other way. You just drag and drop it here. But now, of course, we have the same files. So this is quite easy. Again, what you need is probably to talk to your local IT administrator to install the software. Okay, and now I will give the floor to my colleague Kimmo Mattila, who will show how to a kind of example use case which emulates how to use the resources for actually doing some science.
Okay, hello everybody. My name is Kimmo Mattila, and here is a kind of a sample case of how you actually, what does it look like when you use these services. Let's see if I get this video running. So let's say that you are having your nice afternoon browsing net, and you will get actually a message from your boss saying that, where do I start it? Sorry. Okay, that hey, here are some tasks. I have now here 3 HMM models, kind of biological models describing genes or something like that, and says that could you do a test on these datasets which are available in the internet, and pretty soon, please. And well, what do you do? Actually, you could do this task also in your local computer, but each of these data files which are available from the NCBI in USA, they are several tens of gigabytes in size, and doing this kind of computing would take some days in your laptop. So instead, you use CSC to solve the task. So to use it, first of all, I need to get access to this data. So I don't need to download it to my own computer. Instead, I download them directly to the CSC environment. So what I'm doing here now is that I'm opening from my Mac connection to Taito Shell, which is the place for interactive working in Taito environment. So what's perhaps the biggest kind of starting threshold in starting to use this CSC environment is that here is the environment, no graphical user interface, nothing to click, but instead command line, which operates with just typing commands to this thing that we call as command shell. I have to stop this for a moment, and I go a little bit backwards. Why doesn't it react for me at all? This. Sorry. Yeah. Yep. So first of all, when I'm in here in Taito, I move as the first thing to my work directory. In this Taito environment, you have home directory, which is very limited, but you have in the work directory 5 terabytes of temporary storage space where you can actually then manage your data and work there. I first make a directory for my data called today and move there. And then I open a new file or start creating a new file there. I copy paste the names of the data entries that I need to analyze directly to Taito, meaning directly to the Kajaani. And then I load the software environment I'm using. So I have already checked from the research CSC pages that what tools I need and how they are available. So I know that, okay, by running this model load biokit command, I will get most of the tools that I will need available in command line. Then I start parsing that what kind of commands I need to actually run. I first mistype one command and it doesn't hurt anything. It just shows me that this kind of command doesn't work. And then I try the command again and see the basic syntax how it used. So now I know that I would need to run this kind of a command for all of these files here in this list. So I could type them one by one there if I need it. However, downloading this file even to Taito will take quite a long time. So instead, I interrupt this interactive command and write another file. Actually, I copy first remove the partly downloaded file and then create a new file which I edit so that I put here a command that I want to execute for each of these files. So now I have my kind of a very simple script saying that run these commands. Each of these commands will run will download one of the datasets from the NCBI service in USA to my environment here in Taito. And I save it, and then I use a tool called SPATS command list, which I first check how it works with option -H. And notice that, okay, by giving the file name to option commands, I now submit these files to be executed. And now I have here 6 files running. And I can leave them there in the background while I'm then starting to transport the HMM models which I need for the comparison from my email to this Taito environment. So I first now download them to my own local environment. And then I could use FileZilla like Ate used just a moment ago to copy them to Taito. But now I will use another service which is called POTA object storage. And I'm using it here because I don't happen to have FileZilla installed here, and this POTA object storage is based on browser interface, so you don't need to install anything if you have a POTA access for your project. So I log into this graphical user interface of the POTA cloud environment, and there go to containers, And I have several containers there. Now I'm using a container called using CSC. I select that, open, and then I go here and start uploading the files. Just like in normal web application, you go to your local environment, choose the application, upload it, and same thing for the next one. And the third one still there, and now I have uploaded the data to the object storage. I can see the files there, which these HMM named files there available. And now they are not yet in Taito. They are in a kind of on the halfway between Taito and this my own environment. So I can still here see that the jobs haven't even started yet. They are still waiting there in the batch shop, and that doesn't hurt. I could actually close this connection, and the jobs would be still progressing there. But I don't need to do that because I can have several connections open to Taito in the same time. So I open another session to Taito and go to the very same directory. First, go to Taito shell with my user account. Go in, and then move to work directory, and there the today directory that I just created, and now I list the same files again. So now what I could do is that I use command s3cmd, which is a command line interface for this both object storage service. I can see here now my using CSC folder, and if I go further, I can list the files what are there, and now I can just with one command, moving this changing this ls to get, download the 3 files that I uploaded to the both object storage, and now I have the HMM files here available. So, and I can check one of them, what do they look like. So now I just need to wait that my target files, those other files are coming, and I check the queuing situation, and that is what is typical in Taito, that the queues are very long. But if you check the queues there, you can see that many users have several jobs running in the same time, and you should also do so. Now, after a while, I don't have any more jobs there available. The data has been now downloaded, and you can see the new files here. I clean the directory a little bit, removing the array of temporary files from there, so I can see better what has been happening. And now I have my data there. So I have the HMM files here, and here are the FastQ files which I downloaded directly from NCBI in my directory in Taito server locating in Kajaani. The data never came to my own laptop. So next I start analyzing them. I have the data available, and I can start doing the analysis. For that, I first need to convert these FastQ files to a little bit different format, to a format called FASTA. But it is just a kind of modification command. It doesn't take too long, so I could submit these jobs also as batch jobs. But in this case, they are faster, so I just execute them one by one, so that I can do this kind of interactively. And after a while, I have converted all these files. I have now more files there as I converted these ones. So I will remove the FastQ files, typing command rm, and star means that all files that start with something, or star means any command string. So sorry. Yep. So and now I will come to the actual analysis part. I would like to use command called nhammer to do the analysis, where I compare these HMM models to these datasets that I have downloaded to locate, to check if these files here contain genes described in with these models. So if some of these samples contain certain genes which are described with these HMM models. And so I want to run this kind of command. I first run it just without any parameters, so I can see the basic structure of the command and check what kind of options it requires. How do I kind of construct the command? And I will build a sample command here. So I'm using 4 CPUs and putting some options here which describe what kind of stuff I want to, what kind of parameters I want to use in the run. And then I launch the command interactively. It starts, but I will interrupt it because I know that this command would take quite a long time to run. So I want to also run these commands instead of interactive work as a set of batch jobs. So what I will do, what I could do here is just like what I did in the case of retrieving the data, manually type a file which contains all the commands I want to run. In this case, I want to run analysis for 3 files, 3 HMM files against 6 FASTA files. So it would mean that I would need to execute 18 commands in total. I could easily write this command by hand also, but here I'm a bit lazy. I'm using the scripting capabilities of Linux environment and type kind of 2 for loops, which creates me the file which contains all the combinations of the query HMM file and the target FASTA file. So this is not the kind of normal stuff you need to do immediately when you start using this environment, but when you get with experience and get more lazy, then you use this kind of tricks to speed up your work. But you could easily do this just by typing 18 different command lines in one file. So let's go a little bit further here. And so, and now we are done with that. And if I now check the files again, I have a new file called HMM commands. And if I check it, it contains 18 different HMM command lines, which I would then submit, which I will submit with the very same way I did with the previously with the SBATS command list. So I give the name of the commands here. I also define I'm using 4 threads, meaning 4 processors for each of these files, of these jobs. So I'm using now 18 times 4 cores in total. And now there's more free space in the environment, so they will start running immediately, and many of them are already executed. However, I have speeded up a little bit this process here, so it typically takes a little bit longer, but now we are going faster in time. But anyhow, after a while, these 18 commands has been executed, and I have the results then available. So now all the jobs are done, and if I check the situation again with ls command, which lists the file in my local environment, in my Taito environment, I can see that I have now these result files there available, and I could study them further, check how much data they have, when they have been created. And actually the main result in this case, or the summary result, is the array job file in the very end of the list. So I could study that with less command to see what does it look like, and check it, okay, this is the file that contains the results. This is what I need to submit to my boss. So I could, of course, copy it to my own computer and send it through email. But what I'm doing now here is that I change the name a little bit more illustrative. So it's summary.txt. And then what I do is that I upload this file back to the OTA object storage. And there I can define that some files which I want to upload there, I first check the location there where to put it with ls command. And I will put that the same using CSC folder like this. So I now define that copy this summary.txt file to this location in both object storage. And when I add this -P here, what I do is that I say that make this a public. And after a while, it's uploaded there and gives you a link. So I can now send this. This is now a public link, and anybody who has this link can go and check this data file there. So I can now copy this link over there, and if I go to a browser, I can see the file, contents of the file, and I could actually send this link to my boss who asked for the results that, okay, here are the results. I have to change that HTTP to HTTPS there and type it there. And now here are the results to be submitted and studied further. So this was kind of the short overview of how things might go. This is a kind of simplified view, but anyhow, what we did here is that we first collected the data to the work directory in Taito environment, then utilized the cluster environment so that we didn't run the jobs one at a time, but we submitted several jobs to be analyzed in the same time. And then when the results are ready, we'll move the results somewhere where they are needed, for example, to the Pota object storage or to your local computer. So that's about that. How do I get out of this? Is it like that? Back to the slides. Yeah. So this Pota object storage, which I already mentioned, it's quite new service at CSC. It comes along the cPota cloud service. So just that's a good reason to get a cPota cloud access for your project. You don't have to do work with the virtual machines in cPota if you don't want to, but by getting a cPota access, you will get by default 1 terabyte of storage space where you can put this data either for your own groups to use or to be published in the internet. And you can access this service through many different interfaces. We here use the web interface provided by CSC and the S3 command line, but there are also other tools which you can use to manage the data in the cPota cloud environment. And the nice thing is this object storage is, as I demonstrated, that you can access it as well as from your own computer, as from the and from Taito, and from anywhere in the internet if you want. Another more kind of a structured storage service is the EDA Research Data Storage Service. So this service is intended for Finnish universities and research institutes, and here you apply Quota for your data there, but the application is not processed by CSC actually, but your local organization, even though the application goes through CSC. You can get quotas of several terabytes in EDA, and you can use it through web interface or EDA command line client. But the idea of EDA is that while Pota object storage is quite kind of a raw storage place where you can just put files and get them back, and which doesn't provide much more than interface and the place to store your data, here in EDA it is intended for more structured and more finalized datasets. So it's intended for datasets that you want to preserve for your research and which you might want to also share and use in your publications, for example. So when you load in your dataset to EDA, you can get it. You can get a DOI for your data, and you can also link it to other fair data related tools like Kuvain, Etsin, or fair data PAS for long-time preservation. And with these tools, you can kind of make the data available for other users too. Here is a question that can you get up to 100 terabytes of storage in EDA? Well, if you have really good reasons for that, but I would first of all, 100 terabytes is a lot of data also in the CSC scale. It's not something that we can provide just like that. But in general, I would say that the first, if you have this kind of data sets and you need to work with them, try first if you can manage with Pota object storage. Even there, 100 terabytes is quite a lot in EDA. So as I explained, that it's intended for kind of structured data which is already processed and which is assumed to be beneficial also after a long time for the other users too. So I would rather kind of, well, I think that you would need to have very good reasoning why your dataset should be put in EDA if it really requires 100 terabytes of disk space. So, and this, as you said here, that this is gene data in cancer patients, and that's a good note, because what I haven't mentioned here is that all these services that we have been discussing here are intended for data which is considered not sensitive data. So if you have some human patient data that is considered as a sensitive data, then you could you generally cannot use these services, but you have to use the ePOTA secure storage environment and computing environment of CSC. But that's a topic of another seminar. Can you share data in EDA to colleagues outside Finland? Yes, you can, and you can also do that in POTA. So once again, use either of those. POTA is more for a kind of more general raw data that you are still processing, but if you have kind of finished your data analysis and you want to publish your final data set, you can put it to EDA and get, for example, a DOI and attach to your publication, or just use it to share with just a link with your known colleagues.
So this has been the introduction to some selected things that we thought would be very useful to get started. Okay, so there's another question whether ePOTA is in a separate private network, right?
Yes.
And this is correct. Yeah.
Yeah.
So to learn more about the services, we are currently having what we call a roadshow. So we're visiting different institutes and different campuses, and the idea is to promote the services overall of our what we have available, but in particular related to the new supercomputers that will be installed this year and early next year. So from the link at the bottom of the page, you'll find where and when we're going, but we'll probably also send some emails about these visits. So these are nice opportunities to ask for more information and learn once we also learn how the new services will actually turn out. So there's a question, how do I update tools which require the internet connection in VM in ePOTA?
Well, that is a topic that we will discuss in some other webinar, because ePOTA is quite specific environment and requires local settings, and there might be not kind of general solutions, but the case-by-case solutions depending on in which project, ePOTA project you're working with.
Yeah, but you could first check our the documentation on web pages, and if you can't find the information there, then send an email to servicedesk@cscfi. This applies to everything.
Yeah.
So it will be faster if you find it by yourself, and of course it will help us a little bit if we don't have to answer all the questions where the information is already on the web pages. But if it hasn't been formulated clearly, or you're new to the topic, then it might not be so clear. But please don't hesitate to contact us through servicedesk@cscfi. That's it's our goal. It's our reason of being to help you do research, and this is what we do. So to wrap up, Kimmo showed one customer case where a coworker or boss or somebody had some data that needed to be analyzed, and you could have done it maybe on your own laptop, but it would have taken a lot of time. Whereas you found that at CSC environment, the software that are needed are available, and there's a lot of computational resources, so you can actually run the stuff in parallel, and then it was shown one way how to share the results to colleagues or to anyone. And this case was about some bioinformatics workflow that I'm not so familiar with, but it could be anything. It could be molecular dynamics, or I don't know, calculating some structural things for cranes or whatever. In a more overview sense, why we think that using the CSC services is beneficial, because you don't have to make the software installations yourself. So we have tried to install all the more commonly required software. Some of them are actually tricky, and so you don't need to do the maintenance stuff. There are also instructions on how to run the simulation, some examples. The resources have already been paid for you by the government. If we think in a longer term, if you had one nerd in your research group and then who did all the installations, and then he leaves the group, then you might have some issues when something needs updating or so. So in that sense, when the you have some central place where to get support. It's quite convenient. Analyzing data is much faster if and when you can use a lot of resources. And when you get stuck, we have an active help desk or service desk to give support. Thank you for your time. This webinar will be recorded and made available on the webpage. If you have any feedback on how to improve, it would be very useful for us. For example, which topics were missing and you'd like to hear more. In 2 weeks, we have using CSS environment efficiently course here, one-day course here at CSC. The registration deadline is at the end of this week. If you're interested, please apply. The materials of previous courses are already available on the web pages, so you might actually just check those if you think that participating the full day is too much. We will have more seminars and webinars coming this spring, so please check the web pages or join on our email lists to get notified. And yeah, that's it. Thank you for participation, and we'd love to hear any feedback that you probably have. Thank you. And now, if you have any additional questions,
we have still time.
Yeah. If there are no further questions, then thanks again for participation. But you can always send us. We'd like to get feedback if you have any, and you can always reach us through service desk at CSCFI. Thank you.
Thank you.